Sketch the rational function y is equal to x divided by x squared minus 16. So the first thing I'm going to do here is factorize the bottom, and it's a difference of perfect squares, so it is going to be x minus 4, x plus 4. And that tells me that I have vertical asymptotes. And remember, those will be where the denominator becomes 0. We'll have x is equal to plus or minus 4. The top tells me that y is equal to 0 when x is equal to 0. So we've got ourselves a point on the graph. Now sometimes what I like to do with these ones is make myself up a little table and think of the functions that make up this function. We have x plus 4 in the denominator there. We have x in the numerator. We have x minus 4. I've deliberately put them in that order, and you'll see why in a second. And where do they change sign? So you can do this with a straight line as well. So at negative 4, x plus 4 changes sign. To the left of negative 4, it's going to be negative. To the right of negative 4, it's going to be positive. X changes sign at 0. To the left of 0, it's negative. To the right, it's positive. And x minus 4 changes sign at 4. So you could do exactly what I'm going to do here with the number line and not worry about the table. But we've got x is less than 4. Then we'll have x being, negative 4. X being more than negative 4 and less than 0. Then I'll have x is more than 0 and less than 4. And then we'll think about what happens when x is more than 4. And I've got each individual function that makes up the overall function, and then we'll have the y here. So to the left of negative 4, all three of those are negative. And negative times a negative times a negative, or it doesn't matter because dividing does the same thing as multiplying in this sense, that's going to be negative. But once I'm in negative 4 to 0, this one becomes positive. This one is negative, this one's negative. So overall the function is positive. Once I'm to the right of 0, positive, positive, negative, overall negative. And then once we're greater than 4, all three of those are positive, meaning overall it's positive. And it tells us the regions that the graph can be in. Now sometimes you might need to differentiate these to see if there is a turning point. It doesn't matter with this one, so we are just going to go ahead and do our sketch now. So we've got our asymptotes, which are at negative 4 and 4. We know it goes through the point 0, 0. Now, we know from the table that we did that the graph is negative, and therefore it must be here below the axis in this region here. That's where the graph's going to be. It can't be up there. When we move to the next one, negative 4 to 0, we know the graph will be up here and not down here. Moving across 0 to 4, it will be down here, not up there. And then with the x is greater than 4 as positive, it's going to be up there, not down there. So that's what the table tells us, where the graph is going to be. Okay, so it must come in from the asymptote. And it's going to be shaped like that. Now we're going to go back and just look at the overall function. So as we move away from the asymptote and x becomes a large negative number, x squared is going to be a large positive number. So we're going to have the top is an x, the bottom basically is an x squared. As x gets really big and negative, the bottom is going to be much, much bigger than the top, and that's why it's going to head to 0. Now it's going to do the same sort of thing over here for the same reason. If you take x is equal to 1,000, you've got 1,000 over 1,000 squared minus 16. It's a really tiny number. But when x is close to 4, the denominator is close to 0. And so that's why it goes off the top up the asymptote. Now, what can happen in between? Not very much. It's got to come from the asymptote. It's got to go through there. And it's got to go down there. And in this case, the structure of our one, x over x squared minus 16, tells us it's going to be fairly symmetric, which it is, or in fact it's sort of anti-symmetric, a bit like sine x. So that is the graph of the function.